All right, so we're gonna do away with long division. Long division is in the bin for uh, dividing polynomials by one another. What we're gonna do is what's called re-expression. I actually think it's a lot better and it's more understandable as a process for dividing polynomials by one another. I think long division, if you never learn long division with numbers, which I don't think I ever did, certainly doing long division with polynomials becomes very challenging. So as I said, we're going to look at re-expression instead. What we first need to look at is this idea of how we can re-express a number. So let's firstly look at something like 13 divided by 2. Hopefully you would know how to convert that to a mixed number to be 6.5. Which strictly speaking, it can be a bit confusing, but it's 6 plus 1/2, isn't it? Usually in algebra, when we put things next to each other, it means multiplication, but what we really mean is 6 plus 1/2, right? Right, all of these things actually have names, and it's important we know some of those names. This thing on the top in the numerator is called the dividend. This thing down here in the denominator is called the divisor because we're dividing by 2. This 6 here is what's called the quotient. This 2 is the same as this 2. It's the divisor. And I want you to think about this one. This 1 up the top here is actually the remainder. It's what's left over. We divide 13 divided by 2 goes 6 times with 1 remainder. So that's why that's there, right? All right. So what we can do is we can actually think about how we could re-express 13 in terms of 2. So let me show you what I mean. If I had the number 13 and it was something multiplied by 2 plus something, well, let's think how we would do that. Hopefully it's pretty obvious. We're going to put some boxes here just to represent those things that we don't know at the moment. But hopefully you realize if I put a 6 there, it's going to be 6 times 2 plus, you guessed it, 1. All right, so this is a re-expression of the number 13. I didn't necessarily have to choose 6, but I did in this case. I could have chosen 4, and then it would have given me a different remainder, or I could have chosen any number, and it give me a different remainder. But let's have a look at this situation here. This 13 is obviously the same as that 13. It's the dividend. This is the quotient. This is the divisor, and this is the remainder. Okay, because what we're going to do now is we're going to take all these terms and these ideas into polynomial long division. And we'll look at an example of how we can do it a little bit quicker and more efficiently than by doing the long division. So let me show you what I mean. So imagine we had a polynomial like this. We have 6x squared plus 7x minus 20, and we need to divide it all by 2x plus 5. So in this example, the numerator is the dividend, which is this quadratic. The divisor is 2x plus 5. And what we want to do is we want to re-express it. So the way you're going to have to do this when you're doing it with pen and paper is you're going to write out the denominator in sort of 2 spots, and then you're going to put boxes in front of those spots. And you'll see why that's the case in a moment. In terms of how many times you need to put the brackets there, you need to put the brackets, the number of brackets equal to the highest power in the polynomial in the numerator. So I've got a power of 2 here, so I'm going to put 2x plus 5 twice with the corresponding boxes in front. Okay, and this is how we're going to do re-expression. Let's have a think. I need to put something here such that when I multiply by 2x through the expansion, it would give me 6x squared. So hopefully you would agree with me. What times 2x give me 6x squared? Well, that's going to be 3x. And that would give me the 6x squared part. Okay, this 3x though is actually being multiplied by the 5 as well, by expansion, by the distributive law. So 3x times 5 is 15x. We need 15x to be 7x. So I actually need to take away 8x. And that's where we can adjust things in this box here. We're at 15x at the moment. 3x times 5 is 15. I need to take away 8x. So if I put a negative 4 here, well, negative 4 times 2x is negative 8x. So you'll see that negative 4 needs to go here. Okay, negative 4 times 2x is negative 8x, which is what we want because now this term is sorted as well. This is now 7x, which is what we want. And let's check this last one. Minus 4 times positive 5 is negative 20. So in this case, the last term, the constant term, is also sorted. So that means there's no remainder. So this example here doesn't have a remainder. So what we can do is we can actually write our final answer. We can say that 6x squared plus 7x minus 20 is equal to, well, let's look, 2x plus 5 is a common factor to both of these terms. There's one term, and here's the other term. 2x plus 5 comes out the front as a factor, and you're left with the coefficients. You're left with 3x minus 4. So I think it's a bit of a quicker and easier way to apply long division, because I guarantee you, if you do the long division way of this divided by this, you'll end up with a quotient of 3x minus 4. I encourage you to think about what this is. 2x plus 5. What word is it from the previous example that we looked at? You can sort of see it's in the denominator here. See if you can think about what word it corresponds to that we spoke about back on this page. Okay, so here's a problem to finish up and see if you can try it. Re-express 8x cubed minus 10x squared minus x plus 3, all divided by x minus 1. So see if you can re-express it. So you're doing what we did in that previous example. And I encourage you to think about how many sets of x minus 1 you need to set up this re-expression. Let me know how you go in the comments. Good luck.